All right, let's dive in. We're looking at a paper today exploring how to build long chain of thought reasoning into large language models.
It's pretty groundbreaking stuff, especially with those LLMs like ChatGPT that everyone's talking about. They're impressive, but
They can sometimes miss the mark on those really complex tasks, the ones that need us to think through things step by step, right?
yeah, like proper reasoning, breaking things down.
Exactly.
And that's what this paper is tackling head on.
So what's the title? Who are these brilliant minds?
It's called BOLT, Bootstrap, Long Chain of Thought in Language Models Without Distillation,
Catchy.
from the folks over at Salesforce AI Research.
Salesforce, always pushing the boundaries.
They really are, and they've come up with this novel method.
Called Bolt.
Yeah, BOLT for, bootstrapping this long chain of thought.
LongCoT.
Yeah, LongCoT capability, even in those LLMs that were trained on simpler data, like,
Like the short chain of thought data.
right, sure.
Got it. So LongCoT, this long chain of thought, is essentially how would you explain that to, say, someone who's heard of ChatGPT but maybe doesn't quite get all the technical details?
It's all about giving LLMs the power to break problems down into those smaller, more manageable steps.
Like how we think.
Exactly, like us, so they can tackle those more challenging issues.
So instead of just spitting out an answer, it's showing its work.
In a way, yeah. Like, think about planning a trip.
Okay.
You've got your destination, then you got to figure out the route, book flights, find a place to stay. That's LongCoT in action.
Step by step.
Whereas typical LLMs, they're more like, a quick Google search. You get the answer, but you don't see the journey.
There's a really neat visual in the paper, right? Figure 2, I think.
Yeah, figure 2, it shows this LongCoT in action, like a sequence of thoughts the LLM is generating as it works its way to the final answer.
So we're actually peeking into the brain of the LLM.
Kind of. Helps to, visualize the process.
Now, the real challenge is getting LLMs to reliably do this long chain of thought thing, right?
Yeah, and most attempts out there rely on this thing called knowledge distillation. Basically, they train a new LLM to, imitate the LongCoT behavior of an existing model.
So it's learning from a pro.
Yeah, but it's like training an athlete by just showing them videos of Usain Bolt instead of giving them hands-on coaching,
Yeah, you need that practical experience.
It's expensive, and you don't really get to the core of how the reasoning itself works.
You're just mimicking, not understanding.
And that's where Bolt steps in. It's like, okay, let's try something different, something more transparent. And here's the kicker. It doesn't even need to learn from a LongCoT model to start.
It starts from scratch.
Well, it starts with a regular shortcut LLM, the simpler kind.
So how does it make that jump from short to long chains of thought? That's got to be pretty impressive.
So Bolt has this 3-stage process. The first stage is called LongCoT bootstrapping.
Okay, bootstrapping, I like it.
And they use this in-context learning technique to prompt the shortcut model to actually generate LongCoT examples.
So it's like coaxing it to think deeper.
Yeah, exactly.
Yeah.
And the crazy part is they only needed 10, handcrafted examples.
10.
That's it.
Yeah, super efficient.
So it's not about brute force data, it's about finesse.
It's about smart training.
And what happens in the second stage?
So stage 2 is called LongCoT supervised fine-tuning. They take the shortcut model and train it on this newly created LongCoT data.
So it's learning by example now?
Yeah, it's picking up the format, the reasoning elements,
Yeah.
Like imagine you're teaching someone to bake.
Okay, I love baking analogies.
You wouldn't just hand them a recipe, right? You got to show them the techniques, the kneading, the mixing.
The art of it all.
Exactly. And that's what this fine-tuning stage is doing. It's hands-on learning.
Learning by doing and by studying those good examples. Makes sense. And the third stage, the grand finale.
All right, so stage 3 is LongCoT online training. Now the model gets to, refine its skills through practice and feedback, like a master.
Exactly. It generates solutions using LongCoT, and then they have this thing called an outcome reward model that judges the quality of those solutions.
So it's getting graded on its reasoning.
Yeah, and it learns from its mistakes, gets better over time.
Constantly evolving. I like it.
It's a never-ending learning process, which is pretty cool.
So the million-dollar question, does Bolt actually deliver? Does it actually improve these LLMs?
The results, I gotta say, they're pretty impressive. They saw improved reasoning abilities across several different benchmarks, like ArenaHard, MTBench, WildBench, ZebraLogic, even Math 500.
So we're talking diverse tasks here.
Oh yeah, from real-world coding problems to, competition-level math.
This isn't just a one-trick pony then.
Nope, it's showing promise across the board.
And they actually show that improvement visually, right?
Yeah, figure 6 in the paper, it's like a performance trajectory, and you can see Bolt consistently pushing that model's capabilities further with each stage of training.
It's like watching an athlete's progress over time, seeing them get stronger and faster.
Exactly.
Right.
And it's consistent, which is really promising.
Now, I'm curious about the specific reward model they chose, the Armor M Llama 3 8B. Anything special about that one?
Well, they picked it because it strikes a good balance between accuracy and, being concise. They didn't want the model getting bogged down with super long, wordy feedback.
This is like a mentor who's straight to the point.
Yeah, clear, concise guidance, which is key for effective learning.
So it's not just about the algorithms, it's about choosing the right feedback mechanism too.
Absolutely. All these little details matter when you're training these complex systems.
And there's another interesting tidbit from the paper that really caught my eye. The fact that Bolt works even with a base language model, not just an instruct model. That seems to challenge the whole idea that we need these massive data sets of human annotated instructions to build complex reasoning into LLMs.
Right. It's like saying, maybe there's a different path here. Maybe we don't need to spoon-feed these models everything.
Maybe they can learn to think on their own in a way.
And the key might be in that bootstrapping process, the way they use in-context learning to kind of nudge the model towards LongCoT reasoning.
Giving it the tools to figure things out.
Exactly. And that opens up a whole new world of possibilities.
Okay, let's shift gears a little and talk about the actual training process, particularly that online training phase and the algorithms they used.
All right, so they experimented with a few different reinforcement learning algorithms, the ones you typically see in this kind of research: DPO, reinforce, RLO, PPO. But here's the surprising thing. DPO, which is actually a simpler algorithm, ended up outperforming all the more complex ones.
That's unexpected.
Right. You'd think more complex equals better results, but not in this case.
So what gives DPO the edge? What's its secret sauce?
Well, it seems to be DPO's selective sampling strategy. Instead of using all the responses the LLM generates, DPO focuses on the best and the worst ones, the ones with the highest and lowest scores from that reward model.
So it's all about quality over quantity.
Exactly. It's like a coach focusing on an athlete's strengths and weaknesses, not just having them do endless drills.
Targeted training, smart learning.
Yeah, and the selective approach is super important when you're working with LLMs because their outputs can be, all over the place sometimes.
Get unpredictable, yeah.
So filtering out the noise is crucial for effective training.
Makes sense. So it's not just the algorithm itself, but how you use it, how you curate the data that really matters.
It's all about understanding these LLMs, their quirks and all, and finding the right approach to bring out their full potential.
It's like we're still in the early stages of learning how to speak LLM to really communicate with these systems.
We're definitely still figuring things out, but research like
Sure.
this is a big step in the right direction. We were just talking about how the DPO algorithm really stood out in Bolt's online training, beating out those more complex algorithms.
Yeah, it's like a reminder that bigger doesn't always mean better when it comes to these LLMs.
Totally. And it really highlights how important it is to understand the nuances of these systems, how to handle all the noise and variability in their outputs.
It's like a sculptor working with marble. You need the right tools and techniques to find the masterpiece hidden within.
That's a great analogy. And that's what makes Bolt so exciting, It's like offering a potential path towards solving this big AI challenge, building systems that can reason like humans.
It's been the holy grail of AI research for decades, hasn't it?
For sure. And Bolt shows us that it might be possible to build that long chain of thought reasoning into LLMs without needing all those expensive or, hard to get resources.
So it's about making this powerful capability more accessible, more widely available.
Exactly. And the paper really emphasizes how well Bolt performs on all these different benchmarks. Any results that particularly stood out to you?
Yeah, I was impressed by how well it did on the Arena Hard benchmark, the one with the real-world coding problems. The fact that it could significantly improve the model's ability to tackle those, that says a lot.
Oh, yeah. The Arena Hard benchmark is no joke. Those are some tough challenges. So it's not just theoretical. Bolt actually has real-world applications.
Especially in a field like coding, where reasoning and problem-solving are essential.
Absolutely. And it's not just coding. Bolt also did really well on the other benchmarks, like the math and logical reasoning ones, which shows how versatile it is.
It's like this multi-talented reasoning machine.
And remember how we talked about Bolt working even with a base language model, not just an instruction-tuned one? That finding really throws a wrench into the whole idea that we need massive data sets of human annotated instructions to build complex reasoning.
It's like those LLMs might have more potential for independent thought than we give them credit for.
Maybe. And that bootstrapping process, that clever way of using in-context learning to guide the model towards LongCoT reasoning, that might be the key.
It's like giving them a compass and a map instead of just telling them where to go.
Exactly. And that opens up a whole new avenue of research, a different way of thinking about how to build these systems.
Okay, let's go back to that online training phase for a bit and talk about the reward model. That's a crucial piece of the puzzle, right?
Oh yeah, the reward model is basically the judge, the one that tells the LLM how well it's doing. The researchers picked the Armor Emma 3-8B model for this because it's known for being accurate, but also concise, you know? It doesn't give overly long or complicated feedback.
So it's like that wise mentor who gives you insightful guidance but keeps it short and sweet.
Yeah, it's about finding that balance, giving the LLM the information it needs to learn without overwhelming it.
And this attention to detail, this careful selection of the reward model,
Yeah.
that shows how important it is to understand all these little nuances when you're working with LLMs.
It's all about creating the right environment, the optimal conditions for the LLM to really thrive and develop its reasoning skills.
And it's not just about Bolt. This theme of understanding the subtleties of LLMs, it keeps popping up all over the place in AI research these days.
Totally. Like the choice of the DPO algorithm, the focus on data curation, it all points to this growing awareness that we're dealing with complex systems that need a more nuanced approach.
Like we're still learning how to speak LLM to really communicate with these systems and unlock their full potential.
We're definitely still in the early stages, but research like this gives us a glimpse of what might be possible.
So we've spent this deep dive really digging into Bolt and how it's, pushing the boundaries of what these large language models can do.
Yeah, we've seen how it works, those impressive results, even some things that kind of surprised us along the way.
And now I think it's time to, zoom out a bit and think about the bigger picture. What is all this research, all this talk about long chain of thought, reasoning? What does it tell us about the future of AI, where things are headed?
It's definitely pointing towards AI systems becoming more and more capable of, things that we used to think were exclusively human, like reasoning and problem solving.
We've seen how Bolt enables these LLMs to, break down complex problems into those smaller steps, analyze information, come up with solutions in a logical way. It's pretty remarkable.
And that shift from just simple input-output to this, multi-step reasoning, that has huge implications.
It really makes you think about the potential, how AI could change so many aspects of our lives.
Imagine like AI-powered legal assistants that can analyze these super complicated legal documents and give you a clear summary or even suggest strategies.
Or in scientific research, where AI could sift through mountains of data, find patterns that humans might miss, and propose new hypotheses for scientists to explore. The possibilities are kind of endless.
And the fact that the Bolt researchers are planning to open source their data and code, that's a huge step in the right direction.
Yeah, it's all about transparency and collaboration, which is so important in this field.
It means other researchers can build on their work, test it out, explore new ideas. It's how we accelerate progress.
It's like this collective effort to push the boundaries of what AI can achieve. And it's been a fascinating journey exploring Bolt with you today.
It really shows how fast this field is moving and all the exciting questions it's raising about the future of AI and, its place in the world.
If you're interested in learning more about Bolt, you can find the link to the paper in the show notes. And as always, thanks for joining us on this deep dive into the world of AI. We'll catch you next time.